Hello, my name is Maria from mathmammoth.com. In this lesson, we're going to look at whether something is a proportional relationship or not. So here you see two examples, two relationships between the variables x and y. Which one is a proportional relationship, or are both? One way we can check is we look at these ratios formed by the variables and check whether they are in direct variation, or whether these ratios or rates, they can be rates if there's units involved, different units, or here they are just ratios because there's no unit involved. So we check if these ratios are equivalent to each other. For example, 3 to 4 as a ratio is equivalent to 6 to 8. I have told you that we can double one variable and check if the other one doubles also. 4 doubles to 8, yes, and 3 doubles to 6, yes. Or 5 doubles to 10, yes. 3.75, yes, that doubles to 7.5. 2 and 4, 1.5 and 3, yes. That principle works here. However, here it is pretty easy to see that that is not the case. 3 to 6 is a doubling, 5.5 to 10 is not. So this one here is not a proportional relationship. This one is. What other differences can we see? We have looked at the table of values. If we look at the graphs, lots of dots in both of them and they are rising. But notice that in this graph, there's the point 0, 0, and in this graph, not. We look at the equations. They are similar in shape, kind of, but this one has this +1 added. Not only something times x, but there's also +1. Here there's only a number times x. And those three things are the ways to tell that a relationship is proportional. If there's a graph, then the graph is through the origin. It has the point 0, 0 included. And if there's a table of values, then you look at the ratios or rates and check if they are equivalent. You can check if one doubles, does the other one double? If one gets to be 1/3 of the other, does the other one do the same? And then the equation has to be of the form y equals mx, so that x is just multiplied by one number in the equation. So here are those three things. Remember them well. In proportional relationships, the values of the variables are in direct variation. So you can check that if you have a table of values. And the equation is always of the form y equals mx. Note here that if your variables happen to be, for example, d and t, it would be d equals mt. In other words, one variable is some particular number times the other. And then the graph is always a line through the origin. It's not like this or this, any kind of curvy thing. It has to be a line and through the origin so that the axes go right there. The line could go downhill though, like that too. All right, here's now two relationships between variables. Determine if they show a proportional relationship. In the first one, we see the x values go by 1s. 0, 1, 2, 3, 4. The y values go by 3s. 3, 6, 9, 12, 15. That's a nice pattern. Is it a proportional relationship? It's pretty easy to see that it's not if you look at this doubling idea. From 1 to 2, we double. Here we don't, from 6 to 9. But what if I shifted these y values over there to the right so that they became like this instead? Let me copy. X values like this, y values like this, and we added 0 there. Then is it a proportional relationship? Yes, it is. And now we can write an equation. Y equals some number times x. What number? 3x. All right, and then this other, is it a proportional relationship? When one variable doubles, 2 to 4, the other one goes from 90 to 45. But hey, that's not doubling. It becomes a half, 1/2 of itself, a halving. So no, this is not a proportional relationship. One more. Is this showing a proportional relationship? We have a situation where in 1 hour, one worker can wash 6 windows. And then it shows that if there's 6 windows or 12 or 18 or 24 windows, then we have this many workers. So we're here talking about just 1 hour of time. If you have 1 hour of time and you have 6 windows, you have 1 worker. If you have 12 windows and just 1 hour of time, you need 2 workers. Okay, if I double this, yes, that one doubles. If I triple this, yes, that one triples. And we see also here there is the increase by the same number, 6, 6, 6, 1, 1, 1. Does the point 0, 0 get included? If I have 0 windows, I need 0 workers. That works. And I can write therefore an equation. Well, W, do I choose 2 variables W and W? That would be confusing. Let's say if we have D for the windows and W for the workers, then I put here some single number. That's my equation. So this will be 6. The number of windows is 6 times the number of workers. The number of windows that can be washed in 1 hour if I have a varying amount of workers. So yes, this is a proportional relationship. But now let's say I change the situation a little bit. And instead of 1 hour, we now vary the time. But this time we have 24 windows exactly. So the number of windows is not changing. But we are looking at how many workers there are and then how much time they will take to wash these 24 windows. Since 1 worker can wash 6 windows in an hour, if I have just 1 worker, that worker will take 4 hours, right? To wash these 24 windows. And 2 workers can wash 12 windows in 1 hour, so they will take 2 hours to wash 24 windows. And 3 workers can wash 18 windows in an hour. That's not going to go evenly here. Let's skip that for the moment. 4 workers can wash exactly 24 windows in an hour. Yes. So we see an interesting relationship here. Is it gonna be proportional? Once again, no, because when this doubles, this does not double, it actually gets halved. As for the 3 workers, so how long a time will they take? I mentioned that 3 workers would wash 3 times 6 or 18 windows in 1 hour. So they will take 24 over 18 hours to wash these 24 windows. And both of these are divisible by 6. So I get 4 over 3 hours, 4/3 of an hour. The interesting thing about this table of values is that in each case, these 2 numbers, 1 and 4, when you multiply them, you get 4. 1 times 4 is 4, 2 times 2 is 4, 4 times 1 is 4, and 3 times 4/3 is 4. So therefore, the equation governing them is actually this times this is 4. Workers times time equals 4. This is not a proportional relationship though. If I solve for t, it would be t equals 4 over w. So it's not in the form of t equals some number times w, not proportional. Okay, this is all for this lesson. I hope it was helpful.